Good afternoon and welcome to episode 5 of Science with Shinrai Sensei in our Better Together at Science series. Today we're going to be going over the basic structure of our solar system specifically, and we will start with, obviously, the most important piece of any solar system is the star, which in our case we call the sun. Right? Now, the star is the central focus of a solar system. Everything else orbits around the star, right? So, our sun has 8 recognized planets now. They debate still on objects such as, Pluto and Chiron, such like that. But the jury's still out on those. But officially, right now, the scientific community no longer recognizes Pluto and its sister object Chiron as a planet. They recognize them both as Kuiper Belt objects that are dwarf planets or planetoids. But for the purposes of this, they'll just be Kuiper Belt objects. But honorary, we will give them little dinky dots, okay? So there we go. We will honor Pluto here. So I'll give them the name. I don't remember how to spell Chiron off the top of my head. Sorry, guys. All right. So now the sun will go through all the planets and their names, and we will explain some basic facts about most of these planets, right? And that will be the purpose of today's video, okay? So the sun has 8 planets recognized. Mercury is the first, closest to the sun. And its year is longer than its day. Year is longer than day. Because Mercury takes longer to orbit, or takes less time to orbit the sun than it takes to rotate on its axis one time. Its year is longer than its day. So technically speaking, 1 year would be a measurement of a day, as it would be a derivative of a day there, right? Now Venus is the hottest planet, not plant. My apologies, I'm having a little trouble, I guess. So, planet. Venus is the hottest planet, and this is due to its extremely thick atmosphere, right? It has a very thick atmosphere that is very dense and also possesses a large amount of water vapor, actually. And this dense atmosphere, combined all the chemicals in the atmosphere together, creates an extremely thick blanket that covers the planet in a huge insulating barrier that just all that energy that it's getting from the sun, because of its much closer proximity to the sun compared to our orbit, right? Well, it's absorbing that energy but not radiating it back out into space, and so Venus is the hottest planet, right? Then you have Earth, which, I mean, its key thing is that it has life, right? So Earth, you probably know some facts and stuff like that you can name off the top of your head. We have one moon. Unlike all the rest of the planets ahead of us, Mercury and Venus, we have one moon that stabilizes our rotation so that we can have steady seasons that allow for life to flourish, right? There are so many facts about all these planets. I'm not going to get to them all in one video, so I'm just kind of cliff notes on the actual specific of the planets so that you guys know what planets are what and all that. So, surface of Mars is covered in iron oxide. Covered in rust. Because that's all iron oxide is, in layman's terms, is rust, right? So Mars's surface is red because it has a lot of iron on this planet that oxidized due to being in contact with water at some point, right? Then you have the asteroid belt, which, contrary to depictions in movies and TV, asteroids are super far apart, right? Asteroids super far apart. So asteroids are really far apart, and really, if you're flying between Mars and Jupiter, you're not very likely to see an asteroid at any point. You'll see them maybe from a distance, and you might see the reflection of them in like the sunlight, because asteroids are also going to have some level of like icy shell, kind of like comets do, but you're not going to see them very close. You'll have a very hard time hitting an asteroid going through the asteroid belt. It's not nearly as dense packed as we like to draw it in our comics, in our cartoons, and show it in our movies, right? Then Jupiter is the largest planet, both in diameter and in mass. And Jupiter actually is part of the reason why the asteroid belt exists. Because Jupiter's massive gravity has reined in objects that might come from further outside of the solar system, the further reaches of the solar system, right? Jupiter will catch those objects and basically help set them on the asteroid belt. So Jupiter also has acted like a bit of a shield and bit of a deflecting force that has helped to prevent objects from getting further to the inner solar system where Earth is, right? And so we really have Jupiter to thank that, like extinctions on the level of the dinosaurs, where we have a massive meteor come in and just destroy an entire continent. Those don't happen very often, in large part because of Jupiter. So everybody thank Jupiter for his help. Then we get into Saturn. Saturn's known mostly for its rings, right? But also is super low density. The planet of Saturn has a comparable gravitational pull to the Earth, despite having a diameter that is is only a small fraction, is only a little fraction smaller than Jupiter's. It's not, in terms of the distance between the Earth and Saturn in size, Saturn is far closer to being Jupiter size than it is to being Earth size. And yet, despite Saturn looking as big as it is, it's actually relatively small in terms of mass. So its gravity isn't as strong as it looks like it should be, right? Uranus is on its side. Now, there's a lot of discussion in the scientific community on why Uranus might be on its side. Going theories range from anything between comet striking the planet and keeling it over, and let's say a magnetic anomaly happened and Uranus just got caught between the magnetic field of the sun and maybe this magnetic anomaly or something like that, and Uranus got tipped on its side, right? So for some reason that we do not know at this time, Uranus rests on its side, right? Neptune is the furthest from the sun as far as recognized planets go. But Neptune, much like Jupiter, has a very large storm on its surface. So Jupiter is not just known for being the largest planet, but also the big red spot. Well, Neptune has the big blue spot, right? So Neptune has a very large storm on its surface as well that is comparable in size and intensity to the storm on Jupiter, which Jupiter's wind speeds on its on the planet is absolutely insane to think about, right? Jupiter's wind speeds reach hurricane speeds at a slow pace, right? So the wind speeds on Jupiter, nothing that we have structurally right now would probably be able to withstand the wind speeds that exist on Jupiter, right? Then you have Kuiper Belt. The Kuiper Belt is similar to the asteroid belt, and Neptune is responsible for many, Neptune and Jupiter and all these planets here. These planets have kind of reined in some of these objects into the Kuiper Belt that might otherwise be further out in the Oort cloud. But the Kuiper Belt and the Oort cloud are both made of comets, right? So these are both comets. And I should say comets and planetoids. So the Kuiper Belt and the Oort cloud both are comprised of mostly comets, which are a large percentage of their mass is ice, whether that be liquid, whether that be frozen water ice or other chemical compounds that are frozen to make the solid material that we call ice, right? The Kuiper Belt and the Oort cloud are filled with comets that are made of these things, right? So the Kuiper Belt is filled with comets, so is the Oort cloud. But the Kuiper Belt is an actual orbiting, set of masses. And these comets stay in a relatively close orbit to the sun as compared to the Oort cloud, which, as I was stating in a previous episode, the Kuiper Belt, Voyager 2 has just passed through the Kuiper Belt, if I remember correctly. And so now the Voyager 2 is on its way into the Oort cloud, because a lot of people have mistakenly posted, articles and such saying that Voyager 2 is now off into deep space. It's not into deep space until it is, until it has passed out of our solar system, right? And technically speaking, until Voyager 2 reaches the Oort cloud, which there's no telling how many years it's going to take for it to actually reach the Oort cloud, because the Oort cloud, we don't even have an actual estimate, because we can't go out to the Oort cloud and observe it, right? Because it's so far away, and our satellites and our telescopes, we can't observe it from a distance because these objects don't generate light. And the only thing we can do is wait for the sun to illuminate the objects in the Oort cloud in order to see how far away the objects in the Oort cloud would be, right? And so there's no telling how close the inside of the Oort cloud is, much less how far away the outside of the Oort cloud is. So we really have no idea how long it's going to be until Voyager 2 passes out of our solar system altogether. In fact, it's probably going to take, just by some of the estimates that I've seen of how far the Oort cloud is away from the Kuiper belt and the rest of the solar system, right? The Oort cloud is so far away that it will probably take decades for it to reach the inner portion of the Oort cloud, and another year or two for it to pass out of the outer portion of the Oort cloud. So it'll be the majority of a human lifetime before, before Voyager 2 has officially left our solar system. And it's taken the better part of a human lifetime. At this point, it's taken at least 2/3 of a human lifetime to get from Earth through the Kuiper belt. But the Oort cloud is, just as its name implies, as far as our understanding goes, right? The Oort cloud is a 3-dimensional just halo. Instead of being a ring, a halo kind of thing like the asteroid belt and the Kuiper belt, I chose the wrong word. So the Oort cloud, just like the word cloud implies, it's just this 3D mass, like an atmosphere kind of thing for the Earth or other planets. The Oort cloud just sits all the way around the sun. All 3 dimensions covers the sun. Completely blocks the solar system off from the rest of the universe, really. Now, whether or not this is typical of other solar systems, we really can't tell, because we can only observe the largest objects in many solar systems, and oftentimes we're just hypothesizing whether we're even observing objects in other solar systems, right? But the Oort cloud is just a massive spherical barrier that closes our solar system off from the outside. And we, like I said, we just don't know if that's normal, or if that's how most solar systems operate, or if we're somehow unique in that way, right? But this is just the basics of our solar system. And if you guys want me to, please leave a comment down below. I can get further into details on the planets. If you guys want, I can look up as much information on the planets as possible and do full-blown, in-depth videos on each planet and go through facts on each and every planet that I can find. Or if you guys are okay with just the Cliff Notes version that I did here today to kind of basically understand and explain the solar system and our solar system, then, you know, leave a like, please subscribe, and comment down below any questions that you have, anything you want me to cover in the next science episode, or if you have specific topics you want covered or something like that, please just let me know. And I will see you guys in the next one.